Hello. In this series, I want to explain stable diffusion. My goal is that I myself learn this stuff so good that I'll be able to explain them, and I hope that if you watch these videos, you'll be able to learn them as well. Okay, so let's talk about generative modeling in general. So, generative modeling means that having a data set and trying to find new samples for that data. Okay, so for example, here I have some data points. I try to find the relationship between these points. These points probably belong to a line, so I draw a line, then I sample from that line, right? And this will give me my new data. Okay. So, but finding this relationship in our data is much more difficult in like real world data. Like for example, you have like a bunch of images, or maybe I don't know 1 terabyte of text, and then you want to have a generative model that can generate text or an image, right? So a lot of the topics that I want to cover is part of a course by Professor Jeremy Howard, which is Deep Learning Foundations to Stable Diffusion. And if you're familiar, Professor Jeremy Howard has a long history in deep learning. Okay, let's talk about different type of generative models. So we have autoregressive models. These are models that take a sequence and then they try to predict the next part. Okay, so for example, ChatGPT, GPT-2 and 3 are autoregressive models. They take like I think maybe 32 tokens and then they predict the next one. Okay, and we have variational autoencoders, generative adversarial network, diffusion models, energy-based models, and like flow-based models. Uh, Here we want to focus on diffusion models. Okay, variational autoencoders and GANs were popular in like 2010s. There were many papers for example, for GANs, like cycle GAN, style GAN, I don't know, Pix2Pix, and they were like the first generation of generative models that could generate very high quality images. Okay. Uh, for image generation, we could use these three, like VAE, GAN, and diffusion, but I want to talk about their differences. Okay, so first let's talk about the output quality. GAN and diffusion models can produce high quality images, okay? But VAEs, on the other hand, the output images are blurry, okay? Uh, Training stability, if you are familiar with GAN, you know that GANs have like two different networks. They have to work in balance with each other, okay? And it is like a very like new topic in for AI. For like deep learning models, you have to work in balance, nothing like minimizing these kinds of things. Okay, so they are very unstable to train. They might go through mode collapse, which means that your model might be which means that your model might generate similar things over and over. Okay? But diffusion and VAE are very stable. Okay, especially VAEs are just really easy and very stable to train. Okay, but the problem is here, the output quality. Okay, and let's talk about generation speed. Generation speed means that after training, how fast can your model generate an image, okay? And for GAN and VAE, you just have to train your model and then just run your model, okay? For each run, it gives you a new image, okay? But for diffusion models, the problem is here, this generation speed, okay? So in the early versions of DDPM, for example, you had to run your model 1000 times before getting one image, okay? Like, I think in some comparisons, GAN was like 2000 times faster than diffusion, okay, for generation. And another thing is that another massive point for diffusion is that diffusion models can be conditioned on, okay, which means that you can give it an input, okay, you can have some control over the output image, okay. So for example, you can give it a text input, or I don't know, maybe a mask, or I don't know, some drawing, anything, okay, to control what is the generated output, okay. So for example, here I give it a text like an astronaut riding a horse, and it generates for me. Okay, so I didn't want to go through too much detail about like GAN and VAE because I don't want to explain them. But in the next video, I'll talk about the theory behind diffusion. Thanks.